meter and it accelerates uniformly at negative 9.8 meter per second squared. A ball is dropped from a height of 100 meter. So that means the initial position of the ball is 100 meter. Is that right? Because we take the origin at the ground. We are holding the ball at a height 100 meter means the position. This time, because the ball is moving vertically, we use Y for the position. When the objects move horizontally, we use X for the position. When vertical motion is considered, we use Y for the position. All right, what do we need to find? How long does it take for the object to fall to the ground? You see, how long will it take for the position to become 0? When it falls to the ground, its position will be 0. You understand that? Initially, the object is at Y equal to 100 meter. And when you drop it, it falls, and we need to find the time taken for that Y to become 0. That is the problem. Okay. The ball is at Y equal to 100 meter at T equal to 0. So we say Y of 0 is 100 meter. Now here's the ball placed at a height of 100 meter, and this is the origin, which is Y equal to 0. Since the ball is dropped, we said the ball is dropped. What is its initial velocity? Well, initial velocity is 0 because it is dropped. Nobody used any force to throw it down. So we say initial velocity V0 equal to 0. So we know Y0 is 100 meter, V0 is 0. Okay. And we know the acceleration function. Acceleration is negative 9.8 meter per second squared. Now you might be wondering how I write the unit. Look at that. Meter per second squared. Second squared is in the denominator. Now, the standard form is don't leave a unit on the denominator. Second squared on the denominator is second to the power of negative 2. So read it as meter per second squared. Meter times second to the power of negative 2. Alright. Velocity V of t is obtained by integrating the acceleration function. So we get V of t is integral A of t dt, and A of t is negative 9.8. So let's replace that. That will be integral negative 9.8 dt. Can you integrate that? Integral A dt is A. Integral A dt is AT plus C. Is that right? Integral negative 9.8 dt will be negative 9.8 t plus C1. C1 is our first constant. Now, how do you find this C1? Well, we can find the C1 because you know the velocity at a given time. There you go. When t equal to 0, when this t equal to 0, the V is 0. Therefore, we say 0 equal to 0 plus C1. I hope you understand here. When you replace this t by 0, this will become 0. And at that time, the value of velocity is 0. That's why it becomes 0 equal to 0 plus C1. And what is therefore the value of C1? C1 is 0. So our velocity function is now V of t is negative 9.8 t. That's right. All right, we got the velocity function negative 9.8 t, and also we know that at t equal to 0, the position of the ball is 100 meter. And now we take the velocity function, integrate it to find the position function. All right, Y of t is integral V of t dt, and replace this V of t by this negative 9.8 t. So that will be integral negative 9.8 t dt. Can you integrate this? This negative 9.8 is a constant, so that will not change. If you integrate t dt, it will be t squared over 2. T to the power of 1 plus 1 over 1 plus 1. So this will be negative 9.8 times t squared over 2. There you are. Negative 9.8 t squared over 2 plus a constant c2. So our function is y of t equal to negative 9.8 t squared over 2 plus c2. How do you find the c2? Well, using that situation given to us. What is that situation? That situation tells us that when this t is 0, you replace this t by 0, then the position is 100 meters. When t equal to 0, y equal to 100. So we can write 100 equal to 0, this will become 0, plus c2. That's right. Now I simplified this. You see, 9.8 divided by 2 is 4.9. So this is negative 4.9 t squared plus c2. And now we know that when this t is 0, y is 100. Use that. We get 100 equal to 0. This becomes 0 because when you replace y by 100, you need to replace t by 0. And that gives you c2 equal to 100. And take this c2 into here, we will get the position function. So we got y of t is negative 4.9 t squared plus 100. This is the position function. But how do we answer our question? Our question is, what is the time taken by the ball to fall to the ground? When the ball falls to the ground, what is the value of this y? Y will be equal to 0. In other words, the time taken by the ball to fall to the ground is the time taken for this y to become 0. So all we need to do is set this equation equal to 0 and solve for t, which actually you can do on your own. So when the ball falls on the ground, y equal to 0. So we say 0 equal to 4.9 t squared. Well, negative, that must be negative there. Negative 4.9 t squared plus 100. Or 4.9 t squared equal to 100. That gives you t equal to 4.5 seconds. Well, it will give you two values of t, one positive, one negative. You don't need the negative values for time. So this is the time the ball will fall to the ground in 4.5 seconds. Again, look at that, how neatly we can use the method of calculus to solve fairly complex problems in moving objects.